Welcome to your Day 5 mixed review of Unit 8. We're largely going to focus on similarity proofs as well as solving for missing sides and some more challenging pictures that I can give you. Alright, so starting at the top here, guys, I'm giving you that DE is perpendicular to AC and AB is perpendicular to CB, so I have some right angles going on. Now we're looking to show that triangle ABC, which is this guy right here, and I'll actually pull them out too, just so that we get that visual. ABC is similar to AED. Okay, so based on the givens, I know I have some right angles in there. Now, it's not going to be beneficial to use the angle over here at DEC because it's not within the green triangle. So right at E in the green triangle, let's call that angle 1. And in the pink triangle, let's call that angle 2. You technically could call it B, but I like to match numbers together. So right now, as it is, guys, I know perpendicular lines create right angles. So I have two right angles that are congruent to each other because all right angles are congruent. Now, between the pink triangle and the green triangle, I notice that they're overlapping at angle A, meaning that's a shared angle. Remember, that's our reflexive property. So in this picture, my triangles are similar by angle-angle similarity. Therefore, I then have my proof done. Okay, so this is relatively quick. So remember, we set up our statement and reasons chart, and we write down our givens at step 1. Now, the first thing I should say about angles 1 and 2 is that they are right angles. And that's because perpendicular lines create right angles. From there, angle 1 is congruent to angle 2 because all right angles are congruent. Okay, so at this point in my proof, I have shown one pair of angles. Now remember, we need two pairs of angles, so we still need to talk about angle A. So at step 4, I'm going to say that angle A is congruent to itself. Again, that's your reflexive property. So now you have two pairs of angles in your proof, which means then at step 5, we can now say that triangle ABC is similar to triangle AED by angle-angle similarity theorem. And you're done. I always like similarity proofs because you're just talking about the angles, not the sides. All right, so it says, using the diagram for question 1, if AB is 10, so let's label this, BC is 8, AC is 9, and AE is 5, find AD. Okay, so I labeled it in my separated image. I felt that that was easier to identify that way. Now, it's really important, guys, to pay attention to who corresponds to who. So use my picture to help you. Between the double arc and the right angle, I'll color code that. Those correspond together. Likewise, from the double angle out, those correspond. And then whatever I have left those correspond together. So you'll actually notice that the 8 is just extra information here that we're going to end up not needing because he doesn't correspond to anything useful in my smaller triangle. So when I set up my proportion, I can say 10 is to 5 as 9 is to x. And from there we can cross multiply and solve. So we get 45 is equal to 10x. So I'm getting x to be 4.5. All right, so now we're on the next page. So in questions 3 and 4, you guys will see that they're giving me parallel markers. Okay, now just like what we did last unit in Unit 7 with scale drawings, this tells me then that I can compare the small triangle to the big triangle. Now again, this is the case because these triangles are similar. I'm actually going to get rid of those little pictures right there. I know they're similar because if these sides are parallel, then that means angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, because each of those are corresponding angles. Okay, if two parallel lines are cut by a transversal, corresponding angles are congruent. So that means that the 5x is going to correspond to the 45, and the 20 is going to correspond to the 36. So part to whole, part to whole. Big triangle, little triangle, big triangle, little triangle. So in order to solve, we simply say 5x is to 45 as 20 is to 36. Okay. Now from there, guys, we can cross multiply and solve, or if you guys want, you actually can reduce this before you cross multiply just to make the numbers a little bit nicer. Like I'm looking at the 5 and the 45 and saying, all right, I can actually reduce that to 1/9 because each of those reduced by 5. So this is x over 9. And over with the 20 and the 36, each of those divide by 10, or excuse me, divide by, I could do 2. I also could do 4. If I divide each of those by 4, that would leave me with 5/9. Ooh, this actually works out really nicely. Now, this is kind of nice, guys. If they each have the same denominators here, doesn't x just have to be 5? Now, that's just a coincidence that that worked out that way. You can always, guys, just cross multiply and solve right from the get-go, but it's kind of nice to notice when you can reduce stuff to get to solve. Let's just say, hypothetically, even these denominators didn't reduce to be the same. You could solve this as cross-multiplying 9x equals 45, so x equals 5. Okay, at the end of the day, that's how you solve. Now, I know you guys can cross multiply and solve. I'm just trying to show you guys some strategies that might make your life easier, especially if down the road you take a test that's non-calculator and it's helpful to reduce numbers before making them big, because I don't know 36 times 5 really quickly, but I knew I could reduce it to make my numbers nicer. Okay, so same idea over here at 4. These are parallel, so that means that the small triangle and the big triangle will be similar. So that means I can compare the 25, which is this part right here, to the whole, let's call that x, as well as the 15 to the whole. Okay. So I can do this. Again, make sure you're doing the same corresponding order. Okay. Now, from there, guys, if you want, again, you can reduce this. I can reduce each of these by 3. And then cross multiply from there. So 25 times 8, that's 8 quarters, which is $2 or 200. 200 divided by 5 would give me 40. And that would absolutely work. Now, the way that I actually solved this initially is actually me using side splitter. Because I know these are parallel, I know the sides were in proportion, so I could say part to whole equals part to whole. You could use similar triangles like we did in the previous, meaning small triangle compared to big triangle. But if that's the case, you'll notice that the triangle that I covered in green has some missing side lengths. So if this whole is x and this part's 25, this little section right here would be x minus 25, the whole minus the part. Likewise, on the other side, that would be 24 minus 15, which is the same thing as 9. Okay, so if you wanted to solve it this way, you would do 9, so part is to whole, as part is to whole. So as, here, actually, let me move this over a little bit. I wanted to erase this. Part is to whole, as part is to whole, and you could cross multiply and solve from there. You would get the exact same answer that I did before. Okay, so I'll leave that solving free if you want. Either way, you will get x equals 40. All right, a couple harder examples here, guys. For number 5, it says state the triangles that are similar and solve for x. Okay, so based on the picture here, I'm seeing that little guy, and I'm seeing this bigger guy. So just like in that previous problem we did on page 1, I'm recognizing that there is a shared angle A. Okay, this is definitely going to be helpful to pull the triangles apart to help us out. So triangle ABC, which AB has a length of 10 and BC 8. And then I'll pull out this pink triangle, which is AED. Include those angle markers to help you guys. It's going to be important at the next step. That x plus 2 is supposed to be along ED. All right, so from there, guys, let's pay attention to who corresponds to who. So between the double arc and the single arc, I'm going to map those up. And I'll actually grab a highlighter. From the double arc out, from the double arc out, and then by default, those last two. Okay, so based on my work here, guys, I can say that triangle ADE is similar to triangle, now follow the same colors. So ADE went purple to blue, so ABC in my other triangle. Okay, those are similar by angle. Now let's solve for x. So in order to solve, I see that this has a corresponding pair. So 2x minus 2 is to 10 as x plus 2 is to 8. Okay, so now we're good to go. We can set up and solve. So this is 8. I'll actually distribute as I go. 8 times 2x minus 2 is 16x minus 16. Okay, distribute the 10 when you're cross multiplying. 10x plus 20. All right, so I can subtract the 10x, and that would leave me with 6x. Add over the 16, and that leaves me with 36. So I'm getting my final answer to be x equals 6. All right, let's do the next one. State the triangles that are similar and solve for x. Okay, so I'm seeing that angle H in this picture is congruent to angle D, and then there's that shared angle at G as well. Okay, so I'm seeing, again, let's pull these apart. This guy. which is HDG. And the big guy. Okay, so based on our correspondence here, or based on our angles, I can see that these guys correspond between the double arc and the single arc. From the double arc out, from the double arc out. And then you got your last guys from the single arc out. So as far as triangles that are similar, again, follow the color patterns here. I can see that triangle GDH is similar to triangle. Now I went yellow to green, so I'm going to do the same thing. Yellow to green, so GHJ. So now from there to solve, let's map up corresponding sides. 2x minus 2 to 7. As 2x plus 4 to 10. And color coding makes life real simple, guys. If you don't color code or do some sort of patterning, it's just going to be such a difficult problem to solve. Okay, so from there, this is 10 times 2x minus 2 equals 7 times 2x plus 4. So we'll distribute. Okay, so subtract over the 14 from the 20x, that leaves me with 6x. Add over the 20, that gives me 48, so it's looking like x equals 8. And then we're done. All right, one last problem for our review day, for our review video, and it's a little proof here. So in this proof, we are given a square. So this whole outside figure, ABCD, is a square. I'm also giving you that angle 1 is congruent to angle 2. All right, so I'm looking to show that DGF is similar to BEC. So in order to do so, we need to make sure that we have two pairs of angles congruent. So one thing I'm going to teach you guys is pretty familiar with what we've done in quadrilateral units, or things that we've talked about, and the other is going to be brand new to you guys. So first of all, let's start with the square idea. I know that angle D is congruent to angle B, because if you think back to Unit 6, we learned that opposite angles of a parallelogram are congruent. A square is a parallelogram, so this statement will still be true. So angle D will be congruent to angle B. Additionally, now this is going to be new for you guys, I actually can show that the angle that I'll put right there at G is going to end up being congruent to the angle over there at G. Let me actually do some different markers in there. Actually, yeah, 1, 2, 3, 1, 2, 3. And that's because supplements of congruent angles are congruent. It's because we have linear pairs here. Okay? Now, this should make sense to you guys, because let's say you have two sets of linear pairs and you know that these angles are congruent. Like, let's say this is 100. So each of those is 100. Wouldn't it make sense that the other angles must also be then 80, which then in turn would be congruent to each other? Okay, so using that idea, I can actually show that angles 3 are congruent to angle 4, so then I can prove the triangles to be similar. All right, so here we go. All right, so at step 2, we're going to go ahead and say angle B is congruent to angle D because opposite angles of a square are congruent. Done. Okay, that's one pair of angles for us. Now, as far as getting angles 3 and 4 congruent, it's going to take us a couple steps here. So we're going to do angle 1 is supplementary to angle 3, and angle 2 is supplementary to angle 4. And our reason is linear pairs are supplementary. Now, based on our given here, guys, we know that angle 1 is congruent to angle 2. So check that out. If 1 and 2 are congruent, then it must be true that angles 3 and 4 must be congruent. So I'm going to go ahead then and say angle 3 is congruent to angle 4. And that's because, now this is new, supplements of congruent angles are congruent. So guys, now I have everything I need. I have angle B congruent to angle D. I have angles 3 and 4 congruent. So now at step 5, I can say that triangle DGF is similar to triangle BEC by angle-angle similarity theorem. And that's the first half of this proof. Really more than half, because the rest of this is just 2 more steps. As we discussed back on day 3 of our notes, to get to this cross product takes only 2 more steps. Okay? At step 6, I actually do this in a different color so they stick out. At step 6, we're going to have to write a proportion that would give me that cross product. So remember, you're going to put the things that are being multiplied opposite each other. Okay, this should make sense because there's DG times BC, DG, BC, they're across. BEDF, BEDF, there they are, they're across. Okay, now our reason is corresponding sides of similar triangles are in proportion. Now, in order to get to the cross product, DG times BC equals BE times DF. Remember, that's our justification. In a proportion, the product of the means equals the product of the extremes. And remember, I am a stickler about you saying in a proportion. Reason being, if you don't have a proportion, then you don't have means and extremes. Okay? And that's the conclusion of our proof. So again, these steps that I put in pink, it's pretty much rote. Like, those are always those steps after you prove triangles are similar. Okay? You have to do a little bit of thinking backward for the statement side of steps 6 and 7, but it's nothing too crazy. Remember, they just have to be across from each other. Now, as far as steps 3 and 4, this is something new that I've thrown at you guys, but it's nothing I don't think you can handle. These are steps that you use to prove linear pairs or supplements of congruent angles using linear pairs are congruent to each other. And that's what I did over with angles 1 and 3 and 2 and 4. All right, and that concludes our notes for day 5. So tomorrow in class, we'll continue review, and then we'll plan for your test.